So now that we know how to simplify rational expressions, we're going to do some operations with them. Meaning you should be able to add, subtract, multiply, and divide them. For radical expressions, like radicals have the same radicand. Unlike radicals, do not. So for example, 4 root 7 and negative 12 root 7 are like radicals because this is exactly the same. But something like 3 root 11 and 2 root 5 are unlike because they have different things underneath the square root. To simplify sums and differences, so adding and subtracting problems, you use the distributive property to combine like radicals. So if I had given you a problem like 4x plus 12x, all you would have to do is add 4 and 12 and you'd end up with 16x. That's all we're going to do today. If I give you a problem like 4 root 2 plus 12 root 2, you have 4 root 2's plus 12 more root 2's, so you end up with 16 root 2's. Now you need to be careful that you don't do anything with this here. It stays exactly the same. Just like our x's stayed exactly the same here. This didn't become 16x squared or 2x's. You keep that the same, and all you do is combine the coefficients. So we'll start off pretty easy. Simplify these expressions. So both of these have root 5's on them, so all I need to concern myself with are the numbers. So negative 3 minus 4 more gives me negative 7 root 5's, and that's it. So the next one, a little trickier just because there's a 1 hidden out here. But because both of those are the square root of 10, all I have to do is subtract. So 1 minus 5 gives me negative 4 root 10's. So of course they can't all be this easy. Sometimes they're going to give you things that do not have like radicals. And this doesn't mean necessarily that you can't add or subtract them, just means that you might need to do a little more work first. So you want to make sure that your radicals are completely simplified. If they are, and they can't be combined, then you just leave it. But this one here, 20, is not completely simplified, so let's simplify it. Two things that make 20 are 2 and 10, and then that make 10 are 2 and 5. So I can make a square with these 2's, so I'm going to take that out and multiply it by the 3. And then there's a 5 in here that can't make a square. So if we simplify this, 3 times the square root of 20 is the same thing as 6 times the square root of 5. Now we have like radicals, and all we have to do is add 6 and 2. So this problem ends up giving us 8 times the square root of 5. So the next one, same thing. This guy here is simplified. You can't break 3 down into anything, but we can break down 27. Numbers that make 27 are 9 and 3. 9 are 3 and 3. And then we can make one square here. So I'm going to take a 3 out. So I have that negative 2. I can make a square of 3. And then this 3 has to stay inside. So if we simplify, that term turns into negative 6 root 3's. And then these guys are like radicals. So all we have to do is take 3 minus 6, and it gives us negative 3 times the square root of 3. So the hardest part of this is knowing when to add and subtract and then being able to simplify if they're not already alike. So when we talk about multiplication, we need to remember multiplication that we learned way back in the day. Whenever you have a number outside of parentheses, hopefully you're thinking in your head, distribute. Like if I gave you this, all you would have to do is multiply those guys together and then simplify if you can. We're going to do the exact same thing with this problem. So I need to take the square root of 5 and multiply it by both terms inside of here. So if I multiply the square root of 5 times 2, remember things on the outside can only be multiplied with other things on the outside, and same with things on the inside. So this turns into 2 times the square root of 5. I can't combine them in any other way because 5 is inside the radical. But when I multiply these together, since 5 and 10 are both inside, I can multiply 5 and 10. And then you always want to make sure you are simplified before you box it up. 5 can't be broken down anymore, so that term is okay, but 50 can. So if we break this down into some factors, I can see that I can make a square of 5 There should be a 2. And this 2 is left over. So square root of 50 becomes 5 root 2. And then we're going to add that to 2 root 5. Now this is pretty tricky. They look kind of alike, but remember, you're paying attention to what's underneath the square root. And if they're different, that's all you need to know that you cannot combine them. We cannot add them together. So we're done. I'm going to leave B for you to distribute yourself. And when we have ones like this, all we have to do is double distribute. Just like if I gave you something like 3x plus 4 times 6x minus 8, you would have to distribute the 3x and then distribute the 4. So let's do A together. So I'm going to take 2 root 6, multiply it by root 6. So insides get multiplied together and outsides get multiplied together. And then 2 root 6 times negative 5 root 3. So the numbers on the outside are 2 and negative 5, and numbers on the inside are 6 and 3. And then here's double distribution, because I got to take this and distribute that. So outsides, 3 and 1, insides, 3 and 6, outsides, 3 and negative 5, insides, 3 and 3. And then we simplify. So this term here, 36, is a perfect square, so hopefully that's stuck in your head. That's really 2 times 6, or 12. These guys here are like terms, so we can combine them. 10 root 18, or negative 10 root 18 plus 3 root 18 gives me negative 7 times the square root of 18. And then this again is a perfect square, so it's really negative 15 times 3. If you multiply those together, you get negative 45. Now we are still not done. Things can be combined. Both this and this are just numbers. So we can combine those just like we could any other time with numbers. And if you do 12 minus 45, you get negative 33. And then this is not simplified. We need to break down 18. 9 and 2 will make 18, so 3 and 3. We can make a square of 3. And then 2 is left inside the square root. Since we already had a 7 on the outside, we got to multiply those guys together. And then this is as far as we can go. I know it's very tempting to do negative 33 minus 21, but because this is 21 root 2, it is not the same thing as negative 33. Remember, if you ever get confused, throw an x in there instead of your square root. Now, could you combine those two things? No, you could not, because this has an x and this does not. Same thing with radicals. I'm going to leave you to do B. Just remember this square means that you have another square root of 7 plus 4 here, and then you have to double distribute. So we have added, we have subtracted, we have multiplied. This brings us to division. And division is always a little harder because you end up with a denominator. And remember, you are not allowed to have square roots in the denominator. So we need to do something called conjugate the sum and difference. So conjugates are the sum and difference of the same two terms. The radical expression square root of 5 plus square root of 2 and square root of 5 minus root 2 are conjugates. The awesome thing about conjugates are when you multiply them together, you end up with something that is nice and pretty that has no radicals. And it's because of back in the day, if I had a problem like x plus 2 times x minus 2, if I double distribute this out, something special happens. Our middle terms cross off, and we are left with the difference of squares. Same thing here. These are squares with a subtraction sign in between. And remember, if you square a square root, they go away. They cross each other off. So what happens when you multiply a number by its conjugate is you always end up with no radicals, which is good for us because sometimes you end up with something like this in the denominator, and we're not allowed to leave it. So if I have a problem like A, I need to simplify this. We're not allowed to have radicals in the denominator, so we have to take care of that. So what I need to do is multiply top and bottom by the conjugate of this denominator. And all that means is it's exactly the same terms, except you put the opposite sign in between. On the top here, we end up with 4 times the square root of 7 minus the square root of 5. And on the bottom, we end up with a problem that we will need to double distribute. So on the top, we only have to distribute once. So we get 4 root 7 minus 4 root 5. And on the bottom, square root of 7 times square root of 7, square root of 49. Square root of 7 times negative square root of 5 is negative square root of 35. And then if we distribute these, we get positive square root of 35. And these, we get negative square root of 25. So the top we can't do anything with, so let's just rewrite it. On the bottom, middle terms cross off. We have positive and negative square roots of 35. But on the bottom, square root of 49 is 7, and square root of 25 is 5. This gives us 2 in the denominator. 2 is awesome in the denominator because it's not a radical, which is what we want. But unfortunately, this is not simplified. Since both of these have a 4 here, we can factor a 4 out. Or in this case, since there's a 2 in the denominator, we can factor a 2 out. And you're left with 2 root 7 minus 2 root 5 all over 2. And then just like last chapter, these 2's can cancel out. So your answer to this problem is 2 root 7 minus 2 root 5. Lots of work for just one problem. That's why we don't do many of these. Totally skip B altogether, but I want you to do C. So I didn't leave that many problems for you to do, but they should take you a while. Remember, simplest radical form has to meet these 3 conditions here, so always double check that before you box it up. Write down any questions you have, and we will spend tomorrow in class going over them. Enjoy your night.